Hello students, this is my lecture number 5 on binomial theorem. In this lecture, we will discuss about properties of binomial coefficients. Here we will have total 8 properties. We will discuss their proofs and some problems based on these properties. Let us start our lecture number 5. Let us start property number 1. C0 plus C1 plus C2 plus so on Cn equals to 2 power n. Or sigma r equals to 0 to n, Cr equals to 2 power n. We have to start with this formula. We know that 1 plus x whole power n equals to nc0 plus nc1x plus nc2x square plus so on ncn x power n. From binomial theorem, we can expand like this. Using binomial theorem, 1 plus x whole power n, we can expand like nc0 plus nc1x plus nc2x square plus so on ncn x power n. Or this nc0, nc1, nc2 all are called binomial coefficients. We can express nc0 simply, we can write c0. nc1 we can write like c1. nc2 we can express like c2 and so on. ncn we can write ncn we can express as cn. So the same expression we can write. Simply we can write 1 plus x whole power n equal to c0 plus c1x plus c2x square plus so on cn x power n. Substituting x equals to 1 in this expansion, you will get the result. Put x equals to 1 implies 1 plus 1 in the x place writing 1. 1 plus x whole power n equals to c0 plus c1 into 1 plus c2 into 1 square so on cn into 1 power n. That implies 1 plus 1 whole power n will be 2 power n, c0 plus c1 plus c2 plus so on cn equals to 2 power n. This is the formula. First property. Therefore, c0 plus c1 plus c2 plus so on cn equals to 2 power n. Now property number 2. c0 minus c1 plus c2 minus c3 so on plus minus 1 power r into cr equals to 0. Or sigma r equals to 0 to n minus 1 power r cr equals to 0. Here we have alternate signs plus minus plus minus. Once again we'll start with, we know this expression already, 1 plus x whole power n equal to c0 plus c1x plus c2x square so on cn x power n. Now by substituting x equals to minus 1, here RHS is 0 required. So by taking x equal to minus 1, we will get alternate signs also in the RHS side. Put x equals to minus 1. Now 1 minus 1 whole power n equals to c0 plus c1 into minus 1, c2 into minus 1 whole square plus c3 into minus 1 whole cube and so on cn into minus 1 whole power n. Now 1 minus 1 will be 0, 0 power n is 0, c0 plus into minus minus c1. Now this is minus 1 whole square plus, so plus c2. Next here minus 1 whole cube minus into plus minus c3 and so on. Last minus 1 power n into cn. Therefore, the result is finally c0 minus c1 plus c2 minus c3 and so on. Minus 1 power n into cn value will be 0. Or otherwise this expression we can write like sigma r equals to 0 to n minus 1 power r into cr equals to answer is 0. We'll get r equal to 0 to n. If you substitute, you will get this result. Now let us start property number 3. c0 plus c2 plus c4 so on equals to 2 power n minus 1. Here suffixes, if you observe that all are even power, even suffixes 0, 2, 4 so on. By using property number 1 and 2, we can prove this property number 3. From property number 1, this is c0 plus c1 plus c2 plus so on cn equals to 2 power n, sum of all binomial coefficients is here 2 power n. Next, second property, alternate signs, plus minus plus minus, C0 minus C1 plus C2 minus C3 so on is 0. Already we have proved. Adding these two, by adding these two here, plus C0, C0 plus C0 is 2C0. Here plus C1 minus C1 gets cancelled. Here we will get actually plus C3. This is already here minus C3. Plus C3 minus 3 gets cancelled. So here how many C0s are there here? 2 C0. Next C2 plus C2, 2 C2. And next C3 C3 gets cancelled. Next even suffix is C4. That is 2 C4 and so on. Need not write last term. This is RHS will be 2 power n plus 0 is 2 power n. Now each and every term 2 is there. So write 2 common. C0 plus C2 plus C4 plus so on equals to 2 power n. Now take only this expression C0 plus C2 plus C4 so on equals to 2 power n by 2. This 2 write in numerator, that will be 2 power n into 2 power n into 2 power minus 1. Therefore, finally C0 plus C2 plus C4 plus so on equals to 2 power n minus 1. This is property number 3. Now property number 4, C1 plus C3 plus C5 so on equals to 2 power n minus 1. Now here odd suffixes are given 1, 3, 5. By using property number 1 and 2, we can prove this property. From 1, C0 plus C1 plus C2 so on Cn equals to 2 power n. From 2, C0 minus C1 plus C2 minus C3 so on is 0. Now subtracting 1 and 2. Subtract 1 and 2. Now here odd suffixes, here plus C0 minus C0 gets cancelled. Plus C1 is 2C1. Plus C2 minus C2 gets cancelled. And here we have plus C3 minus plus C3 is 2C3 and so on. So therefore the remaining terms are here 2C1, 2C3 and so on. Here this is minus 2 power n minus 0 is 2 power n again. Now 2 common in each and every term. So C1 plus C3 plus and so on equals to 2 power n. Now take this expression C1 plus C3 plus and so on equals to 2 power n by 2. 2 write in numerator, that implies C1 plus C3 plus so on equals to 2 power n into 2 power minus 1. Now bases equal power should be added, that implies final step C1 plus C3 plus and so on equals to 2 power n minus 1. Let us start property number 5. C1 plus 2C2 plus 3C3 and so on n into Cn equals to formula n into 2 power n minus 1. Or simply we can express in terms of sigma. Sigma r equals to 1 to n r into Cr equals to n into 2 power n minus 1. We know this expansion 1 plus x whole power n equals to C0 plus C1x plus C2x square so on Cn x power n. Differentiating on both sides. Derivative of 1 plus x whole power n into 1 plus x whole power n minus 1. Derivative of constant is 0. Now C1 into derivative of x with respect to x is 1. C2 into derivative of x square is 2x and so on. Cn into derivative of x power n is n into x power n minus 1. Now substitute x equals to 1. Put x equals to 1, we will get the required result. Because here 2 power n minus 1 required. So when you substitute x equals to 1, that will be n into 1 plus 1 whole power n minus 1 equals to C1 plus 2 into C2 x place I am substituting 1. So 2 into C2 1 and so on last n into Cn. X place I am writing 1 power n minus 1. That implies n into 2 power n minus 1 equals to C1 plus 2C2 so on NCN. Finally, the result is last C1 plus 2C2 so on n into Cn equals to n into 2 power n minus 1. This is property number 5. Now let us start note. This is actually property number 5, continuation only. The difference is only here we have alternate signs in the property number 5, all positive terms, but here alternate signs plus minus are there. So C1 minus 2C2 plus 3C3 minus so on n into minus 1 power n minus 1 into Cn equal to 0, or sigma r equals to 1 to n minus 1 power r minus 1 into r Cr is always 0. Same process you have to follow. Start with 1 plus x whole power n expansion. This is 1 plus x whole power n expansion. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Again, n into 1 plus x whole power n minus 1. Derivative of constant is 0. C1 into derivative of x is 1 plus C2 into derivative of x square is 2x and so on. Cn into derivative of x power n is n into x power n minus 1. Now substitute x equals to, now put x equals to minus 1. We will get the result n into 1 minus 1 whole power n minus 1 equals to C1. Here x place minus 1, so minus 2C2. Next plus 3C3. Next term we will get 3C3 and minus plus Cn into n into x place substitute minus 1. Minus 1 power n minus 1. This is n minus 1 is 0 now. This is 0 equals to C1 minus 2C2 plus 3C3 and so on. N into minus 1 power n minus 1 Cn. His answer is already here 0. This is the result. Let us start property number 6. A C0 plus A plus D into C1 plus A plus 2D into C2 so on. A plus ND into Cn equals to 2A plus ND into 2 power n minus 1. Simply the total LHS part we can write. LHS equals to, in terms of sigma I am writing, sigma A plus RD into CR. Here R values are 0 to n. Short form. Total LHS part we can write like this. When you substitute R equals to 0, you will get the first term. If you write R equal to 1, A plus D into C1, you will get second one. When you substitute R equals to, you will get A plus 2D into C2, third term. And so on. If you write R equals to N, this will be A plus ND into Cn. So LHS part we can express in terms of sigma. Now this sigma apply for both the terms. See, sigma R equals to 0 to n ACR plus sigma R equals to 0 to n RDCR. Now this is sigma for only R. That's why A we can write outside the sigma. A into sigma R equals to 0 to n CR plus we can write D outside the sigma. D here sigma R equal to 0 to n RCR. Now this equals to, by property number 1, sigma R equal to 0 to n CR equals to, we know that this will be 2 power n plus, by property number 5, D into this part will be, by property number 5, this will be n into 2 power n minus 1. This is from property number 1, property number 5. Now here 2 power n we can write in terms of 2 power n minus 1. So 2 power n minus 1 into 2 we can write, plus nd into 2 power n minus 1. Now here 2 power n minus 1 we can write common. So therefore 2 power n minus 1 into 2a plus nd, 2a plus nd. So finally 2a plus nd into 2 power n minus 1. This is property number 6. Now property number 7. LHS equals to, this is C0. This C0 can be written as NC0 plus C1. We can write NC1 by 2x. LHS equals to this C0. C0 can be written as NC0. C1 we can write NC1 by 2 into x. This C2 we can write NC2 by 3 into x square, and so on. This Cn can be written as Ncn by n plus 1 into x power n. Actually you know that NCR short form is CR. So CR we can express NCR. That's why I'm writing like this. Now NC0 equals to 1. We know NC1 value is n by 2 into x. NC2 we can write n into n minus 1 by 2 factorial. Already here 3 is there. 3 into x square, and so on. Last NCN. NCN is 1. 1 by n plus 1 into x power n. Here NC2 value is n into n minus 1 by 2 factorial. We can expand NC2 value like this. See, NC2 equals to actual formula n factorial by n minus 2 factorial into 2 factorial. This implies here n factorial we can write n minus 2 factorial form. N minus 2 factorial into n minus 1 into n by n minus 2 factorial into 2 factorial. Now n minus 2 factorial gets cancelled. So n into n minus 1 by 2 factorial. This is NC2 value. Similarly, we can write NC3, NC4 like that. Next, this step equals to, once again, this is equals to n by 2 into x, n into n minus 1 by, this is 2 factorial is 2, 2 3s are 6, x square, so on, 1 by n plus 1 into x power n. Here, the denominator we have n plus 1 into x. In RHS, denominator I have n plus 1 into x. That's why multiplying and dividing with each and every term, multiplying and dividing with n plus 1 into x. Multiplying and dividing with n plus 1 into x. That is, denominator n plus 1 into x division I am writing here. Each term is divided by n plus 1 into x and multiplying with n plus 1 into x. So n plus 1 into x into 1. N plus 1 into x. Next, in this step also multiplying with n plus 1 into x. So n plus 1 into n by 2 into x into x, x square. Similarly here also n plus 1 into n minus 1 by, this is 6 here. This 6 can be written as 3 factorial into x square into x cube, and so on. Last here also we are multiplying and dividing with n plus 1 into x. That's why, see, this is n plus 1 into, by here division already n plus 1 is there, x power n into x, that will be x power n plus 1. Next step, this can be written as n plus 1 c1. n plus 1 can be written as n plus 1 C1. This can be equals to n plus 1 C2. This will be equals to n plus 1 C3. This will be equals to n plus 1 C n plus 1. Here n plus 1 gets cancelled. First term n plus 1 C1x. Second term n plus 1 C2 x square and so on. N plus 1 C n plus 1 x power n plus 1. Now in this bracket add n plus 1 C0 and subtract n plus 1 C0. Add n plus 1 C0 plus n plus 1 C1x plus n plus 1 C2 x square so on. N plus 1 C n plus 1 x power n plus 1 minus n plus 1 C0. Just add and subtract n plus 1 C0. Now this part will be equals to, up to here we can write this is one of the expansion. So 1 by n plus 1 into x according to our property number 1. This is like C0 plus C1x plus C2x square so on Cn. This can be written as 1 plus x whole power n plus 1. This is completely up to underline part is. This is the expansion of 1 plus x whole power n plus 1 minus this part as it is n plus 1 C0. We know that n plus 1 C0 value is 1. That's why this is equals to 1 plus x whole power n plus 1 minus n plus 1 C0 is 1 divided by n plus 1 into x. This is RHS. This is property number 7. Let us start property number 8. This is last property. Proof of this property. We have to start with expansion of 1 plus x whole power n. See 1 plus x whole power n expansion. C0 plus C1x plus C2x square so on CR x power r plus CR plus 1 x power r plus 1 plus CR plus 2 x power r plus 2 so on Cn x power n. Because here CR required, CR plus 1 required, CR plus 2 required so on Cn. That's why I am writing CR, CR plus 1, CR plus 2, Cn. Next same expansion but in reverse order I am taking x plus 1 whole power n next. This is the expansion of x plus 1 whole power n. By using binomial theorem, we can expand like this. C0 x power n plus C1 x power n minus 1 plus C2 x power n minus 2 plus so on CR x power n minus r plus so on Cn minus r x power r plus so on Cn. Because here C0, see observe this Cn minus r required. That's why I am writing Cn minus r also. Similarly here CR is also required. Therefore, we are writing like this. This is equation number 1. This is now equation number 2. Now, 2 into 1. Multiplying these two equations. First, I am taking 2. How to multiply? First, LHS of 2 into LHS of 1. This is LHS of 2. LHS of 1 equals to RHS of 2 into RHS of 1. See? This is RHS of equation 2 into RHS of this is equation number 1. Now to get the result, equating coefficient of x power n plus r on both sides. Why coefficient of x power n plus r? Equating coefficient of x power n plus r. Why? Because here C0, CR required. If you multiplying, need not multiplying all terms. Just multiplying C0 into CR. What is C0 x power r into CR x power r? That means C0 CR, C0 into CR, x power n. This is x power n into x power r. Now this will be C0 CR into x power n plus r. Therefore this term is coefficient of x power n plus r. That means C0 CR is nothing but coefficient of x power n plus r in RHS. Similarly, coefficient of next C1 into, if you multiplying with CR plus 1, C1 into CR plus 1 x power n minus 1 into x power r plus 1. This also gives coefficient of x power n plus r. So that's why first equate coefficient of finding coefficient of x power n plus r in RHS. After that find coefficient of x power n plus r in LHS also. We are finding coefficient of x power n plus r in RHS. C0 into CR plus C1 into CR plus 1 plus C2 into CR plus 2 and so on last. Cn minus r into Cn. Cn minus r into Cn. What is this? Coefficient of x power n plus r in RHS. Similarly, find out coefficient of x power n plus r in LHS also. Next, how to find coefficient of x power n plus r in LHS? What about LHS actually? LHS equals to x plus 1 whole power n into 1 plus x whole power n. X plus 1 is nothing but 1 plus x. So we can write 1 plus x whole power n into 1 plus x whole power n. Now bases equal, so power should be added. Therefore, 1 plus x whole power n plus n will be 2n. In this LHS, we have to find out coefficient of x power n plus r. Actually, this expansion is in this model. 1 plus x whole power 2n expansion is in the form of 2nc0 plus, here index is 2n, that's why 2nc1x plus 2nc2 x square, so on 2nc n plus r x power n plus r and so on 2n c 2n x power 2n x square. The coefficient of x square is 2nc2. Coefficient of x power n is 2nc1. Coefficient of x power n plus r is equals to how much? 2nc n plus r. Therefore, the coefficient of x power n plus r in LHS equals to 2nc n plus r. This is the coefficient of x power n plus r in LHS. That equals to, by expanding this using NCR formula, this is 2n factorial by 2n minus n plus r factorial into n plus r factorial. That implies 2n factorial by 2n minus n minus into plus minus r factorial into n plus r factorial. So now equating coefficient of x power n plus r in LHS and RHS. So equate coefficient of x power n plus r on both sides, implies we will get C0 CR plus C1 CR plus 1 C2 CR plus 2 so on Cn minus r Cn equals to, what about coefficient of x power n plus r in LHS? 2n factorial by n minus r factorial into n plus r factorial. This is property number 8. Let us discuss one of the example. This is previous JEE Mains 2021 question. This is the value of minus 15c1 plus 2 into 15c2 minus 3 into 15c3 plus so on. Minus 15 into 15c15 plus 14c1 plus 14c3 plus 14c5 plus so on 14c11 required. Actually, this problem is combination of two properties. Up to here, up to 15c15 is one of the property. Already we have discussed. And up to from 14c1 to 14c11 another property. So the given expression I am writing, in this first underline part, take minus as common. When you write minus as common, this will be 15c1 minus 2 into 15c2, next plus 3 into 15c3, next minus so on, plus 15 into 15c15, and second part as it is I am writing 14c1 plus 14c3 plus 14c5 and so on 14c11. If you observe this, this is in the form of like c1 plus c3 plus c5 plus so on c11. We have property number 4, c1 c3 c5 and so on c11. Here index is n is 14. The last odd number is actually 13. That's why add and subtract 14c13 minus 14c13. Just we are adding and subtracting here to convert a formula. This is second part now. Now continuation. Minus of, what about this up to here? This is according to our property. This part will be 0 plus remaining part. Second part will be up to 14c13 will be 2 power n minus 1. That means n is 14 here. 14 minus 1 minus 14c13. Here two formulas are there. The first one is C1 minus 2 into C2 plus 3 into C3 and minus so on, alternate signs value 0 according to our note. And second part is in the form of C1 plus C3 plus C5 odd suffixes, sum of odd suffixes formula 2 power n minus 1. Here our n is, index n is 14, that's why 2 power 14 minus 1. 2 power 13 minus 14c13 value will be 14. So this is the answer. Option number 4 will be the answer.